All right, today we have one goal, and that is to get you ready to start programming the first milestone of your big assembler project, which will be the Lexical Analyzer. All right, so what we're going to do is do a code walkthrough. I think most of the time we'll be spending doing the code walkthrough of the implementation of this multiple token parser. So as you recall yesterday, we saw in figure 7.31 this multiple token recognizer, this multiple token parser that recognizes. Now, if you end up in the start state, what token have you recognized? Do you remember? No, well, no, the token. No, if you terminate on the start state, which token have you recognized? Do you remember? The empty token. That's the empty token. And then if you end up in the ident final state, what have you recognized? An identifier. And then if you wind up in the int state, you have recognized an integer token. All right? But then we said, okay, so does everybody remember so this is a machine that we're going to implement. And then in figure 7.33 is the UML class diagram of the tokens. Now, I know some of you have had data structures and some of you have not. If you've had data structures, then a lot of this is going to be pretty straightforward. But even if you haven't, the object-oriented programming that we're going to do is all just very basic standard stuff, and I think it'll be good reinforcement of the object-oriented programming that you've already had. So now, in figure 7.33, we have a token. What does the A stand for in a token? Abstract. That means that and then the get description is a method that is not defined in the abstract token class, but instead it's implemented. It is specified in the abstract class, but it is implemented in each one of the concrete classes. Now, and I think in reviewing the lecture from yesterday, I think I might have misspoken just a little bit. You see this method called getDescription? What it does is, what is its type? What does it return? GetDescription returns a what? A capital S string, and that is a Java string. Okay, and let's go back here to figure 7.32. I think yesterday I might have said that getDescription is responsible for returning the word, on that first line, the word here. It actually is responsible for returning identifier equals here. So it's the whole string that is everybody with me? That's the purpose of getDescription. And it's also responsible on the empty token for printing out the empty token. That string, empty token. We'll see this in a minute, okay? Now, and ask questions as we go. Really important that you ask questions as we go. All right, and then I think at the end of class last time we were talking about the T integer and the T identifier, and we noticed that T integer has a private attribute whose type is int and whose name is int value. All right, and that token stores the integer value of the string of characters that represents an integer value. It stores the integer value of that. And then the T identifier has a private attribute named string value, and what that does is stores the value of the identifier, the string value of the identifier. We'll do a trace and you'll see how this works in a minute. And then T integer, the class T integer also has a method T integer, and because the method has the same name as the class, that is a what? Finally, a constructor. And so, and when does it get executed? When you do what? What operation? What operation triggers the execution of the constructor? New. When you do new. Okay. And when you do new, that's a dynamically allocated variable. So where is it allocated from? The heap. Yeah, so just like in C, Java is just like in C. Your new is allocated from the heap. Okay? And the constructor gets triggered automatically when that happens. So the purpose of the constructor is to, well, we'll see the code in a minute. It's to set the value of the attribute. That's what it will do. We'll see how that works in a minute. All right? Now, before we go on, there's just one demo that I want to give. And I'm not going to demo the execution. I just want to demo the structure of the file system. So let's do a little demo here. Okay, so here's our demo. And what I would like to show you is just something about the file system. Here's our project, Fig 0734. And if we open this up and we look here under source packages, I just want to point something out here. And then under source packages, we have this Fig 0734, and notice the little icon is in the shape of a package. And if we open this up, notice what we have here. We have atoken.java, inbuffer.java, Lex State.java. So every class has its own file, and this is how you need to organize your project, your tokenizer, like this, with each one having its own file. And the reason I point this out is because in the code walkthrough that we're going to do with the slides, I have combined this code from several different files into one slide for our ease of viewing. Okay, but they are, just keep in mind that that each class is going to have its own separate file. Okay, so that's the end of the demo. So now let's do a code walkthrough. So now in Figure 7.34, now here again, notice that we have abstract public class a token, and then public abstract string get description. Now those three lines right there are in a separate file. That's what I just showed you. They're not, so even though they're all on the same slide here, each one of these is in a separate file. Is everybody clear? Okay? And so now in Java, the way you specify an abstract class is with the word abstract. And okay, so is everybody clear on what that abstract means? All right, now, let's go back to our UML class diagram. What is this triangle? What is this in UML? This stands for what? Inheritance. Is inheritance an is-a relation, or is inheritance a has-a relation? Ooh, we had difference of opinion here. Which one is inheritance? Okay, so are we agreed? It is is-a. It is. So what we're saying is that a t-empty is an a token. A t-invalid is an a token. A t-integer is an a token. Is everybody clear? So that is is-a. All right. Now, here in the code, do you see now how in Java, how you do subclassing? It's that, you see here, public class t-empty. Now what do we have after that? Public class t-empty what? Extends a token. So that word extends is how you do subclassing and how you do is-a, how you do inheritance. Is everybody clear on that? What was the symbol in C, or C++, sorry. Well, not close but no cigar. It wasn't colon, colon. Colon, colon was the... Was it just like one colon? Just one colon, yeah. I know it's easy to forget. But anyway, is everybody, are we good? So in many languages, that's the symbol for inheritance. But in Java, you actually you spell out the word extend. So this is how you're going to have to do. This is how you're going to have to make your subclasses. All right. And now look, public string get description, return what with the empty token? It says return what? Quote empty token. So you see, that's where back here in Figure 7.32, that's where the empty token comes in the output. Okay, it's by get description. Is everybody clear on that? And then t-invalid, public string get description, return syntax error. And t-invalid extends a token. Is everybody, any questions now? Is everybody good with this? Okay, now here on the next part of the slide is t-integer. Now, what does t-integer have? Let's go back to our UML class diagram. T-integer, what attribute does it have? What's the name of the attribute? Int value, and what is its type? Int. So let's go to the code. And you see private final int value. So everybody see that that corresponds to the UML class diagram, right? Now the reason it's final, what do we know about, I think we've done Java final before. What do we know about final? Can't change it. So it's like a what? It's like a constant. So what happens is, in this particular app, that value will never change. Once we create a token with that value will never change. So we make it a constant. Is everybody clear? Because we won't ever have occasion to change it. So it'll be set when we do new. We're going to set it to a value. The constructor is going to set it to a value, and that value will never change.
Well, okay, fine. Then I'll ask you.
Oh, actually, that's a good question. I think you're going to see. Yeah. Oh, hold on. Here, since you brought that up. No, this is good. Since you brought that up, let's review mutable and immutable. All right. So now, what did we say at the end of class last time? We said that Java type string is what? Immutable. Now that does not mean the same thing as a constant. And let me give you an example that we have already looked at. Let's go back to public in figure 7.30, public class in buffer. Now do you remember? Do you see here? Public in buffer. Now what is the type of in string? It is a what? Capital S string. That's a Java string. Is that mutable or immutable? That's immutable. That means that you can't take a given in string and change it in place. But what does this constructor do? This in buffer constructor do? It does what? It reassigns it. You see it says in string gets string plus -n. See, so it can be reassigned, but it can't be changed in place.
Gotcha.
And what were the while we're on this topic, are immutable? What is the characteristic of immutable objects? They were safer but slower, and mutable objects are dangerous but faster. Yeah. Okay. So now, to get back to figure 7.34, does everybody see that class T integer extends a token, private final int value, so that's the attribute. And what does the constructor, now what does the constructor do? Oh, did you have a question?
What is the extends function?
Okay, so now remember, extends is inheritance. All right? So, and that's this symbol in UML, and that's inheritance. Sure. Okay, any more? Are we good? Now, I tell you guys, this stuff is real conceptual. You have to have a firm conceptual, if you have a firm conceptual understanding of how all of this works, the coding will not be complicated. But if you don't have a firm concept of the principles, then it's going to be, you won't know how to code. You see, so this is kind of high level. We have to have this high level understanding of how things fit. Okay, and look at what get description does. Actually, this question, somebody asked this question last time. Public string get description, this is for T integer, it returns what? String dot what? Format. So format is a Java method that is provided by the capital S string class, and it works just like it works in C. Remember how we learned how to do the placeholder stuff in C? It works the same way. It's modeled after that. So it says integer space 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 equals, and then %d is the integer placeholder, and then we do int value. Now do you see how that produces, let's go back here to figure 7.32. Do you see how that produces integer equals 48 on this figure? But it takes the int value and converts it over. Does everybody see how that works? Are we good? And now class T identifier extends a token, and then it has private final capital S string value. Now is the attribute mutable or immutable? It's capital S string, Java capital S string. Is the attribute under lowercase s string value, is it mutable or immutable? It's immutable, and not only that, not only is it immutable, it's also what? Final, which means it's constant, okay? All right, so now what does the constructor do? How does the constructor work? The constructor is given what as the parameter? What is the type of the parameter? String buffer. So that's the mutable one, right? That is dangerous but fast, and that's what's in the parameter. So what does it do? So what does it do to the attribute? It does string value, lowercase string value. The attribute gets new capital S string. So what this is doing is this is converting from the string buffer type to the string type to be stored as the attribute of the class. And the reason we do this is because as we are computing the value of the lowercase s string buffer, we're going to be wanting to mutate it for speed. You know, so we want, but then once we get that all set up and ready to be stored immutably, then that's the constructor makes that conversion from the dangerous but fast string buffer type to the slow but safe string type. Is everybody clear on that? This is really good software engineering techniques stuff that comes up all the time. Mutability versus immutability. This is really good coding stuff. All right, and then okay, so and then you see how the what get description does. Identifier equals, and then the %s is the place value, and then string value. Is everybody clear? Yeah, question?
So it's okay for you?
Okay, now we're also going to have a separate, here again, this class util and this enum Lex State. These are in separate files, but they're on one slide here just for convenience. We have this little class util. Util stands for utility. And we have static Boolean is digit. Now what does static mean in Java? What does this static mean in Java? Lots of review here. The same thing as in C, what? Or C++, what? One per class instead of one per object, yeah. So we have is digit, and then we have a Boolean is alpha also. All right, there's the code for that. And here is our Lex State. Now, does everybody see how this corresponds to the diagram? ls start, ls ident, ls sign, ls integer, and then we have an extra one, ls stop. ls stands for lexical state. That's the purpose of the ls. Is everybody good? All right. So this is going to be similar to the way we did our finite state machine before. Now, in figure 7.35, continuing, let's take a look at public class tokenizer. Now, we're actually looking at this code bottom up. So we haven't seen yet how tokenizer is going to be called. So we'll do that in a minute. But let's just see how tokenizer is organized. So first of all, what attribute does a tokenizer have? It has an attribute. What is it? It is it's lowercase b is the name of the attribute. And what is its type? In buffer. Now, we looked at in buffer last time. So is everybody clear? So anytime we have the letter B in our code, what is that? What is that? That is the buffer. That is our in buffer. Are you with me? And what does that in buffer have? It has the ability to feed us one character at a time, the ability to back up input if we need to. Yeah? Is everybody good? So that is an attribute of the tokenizer. And in fact, what is the public tokenizer? Now, public tokenizer, that method has the same name as the what? Class. Therefore, it is the what? The constructor. And so whenever we do a new tokenizer, what do? We give it an in buffer, and what does the buffer do? It does B, its attribute, gets what we pass it in the parameter. Now you see how this is all very consistent. It's all these patterns, these coding patterns are all, are we good? They're all very similar. And now our primary one is this public A token, get token. So get token is going to be called, and we're doing this a little bit bottom up, so here's what we have to imagine. We have to imagine that some program is calling getToken, and furthermore, this tokenizer has access to the buffer. All right? So what let's do now is, to continue our code walkthrough, let's do a little trace. And let's suppose that in our end buffer, we have these, we're going to be past this sequence of characters. Hyphen 9 3 H I. All right? So let's just trace this with, and suppose that this is the stream. This is the stream that the buffer is going to, this is the character stream that the buffer is going to give us. Are you with me? Is everybody clear? And then let's trace the execution of when getToken gets called. All right? So check this out. So what do we have? We have nextChar, which is of type what? Char. So here we have nextChar. We have what? What's the next one? Local string value. Okay, so local string value. Is everybody with me? Okay, and what else do we have? What's the next one? Local int value. And what's the next one? Sign. Now see, some of this stuff should look familiar, right? Because it's going to work the same way we did it with some previous examples. And what's the next one? Ooh, a token. I'm not going to know how to write that down, but we'll take a stab at it. And what else? State. Is everybody clear? So this is what we have. This is what the tokenizer has to work with. All right, and then and now. By the way, it was local int value. Oh, we kind of skipped something here. First of all, when we did string buffer, it was local string value gets what? Yeah, so this one is initialized to the empty string, and local int value was initialized to what? 0, and sign was initialized to +1, and this a token is initialized to what? A new tempty. So yeah, yeah. I said I was going to have a hard time writing this one down. Let's just say the empty token, or yeah. Let's just say an empty token. All right. And then what's and then what happens? State is initialized to what? ls start. All right. Now, so that's continuing. Do. Is everybody clear? Do. Now this do loop is going to be executed once, or we're going to do, and we're going to scan through. And so let's take a look at the test at the bottom. While the state is not equal to ls stop and not abstract token instance of invalid. Okay? So we'll have to see what kind of token it is to see whether or not to stop. All right? And that loop, when we get through at the end of that loop, what will we return? We will return what? A token. So if we come back up here, you see what is the type of get token? What does it return? An abstract token. Now, is everybody clear on that? Because after all, it's get token. So if it's named get token, what will it return? An abstract token. So
That's because we don't know which kind.
we don't know which kind. Yeah, and that's what's so slick about this. We are returning an abstract token because we don't know what kind of token it's going to be. That will vary at runtime. Polymorphic dispatch. Yeah, we're going to use polymorphic dispatch in a minute. Yeah, in a minute. We are. Does everybody see how that works? Okay. All right. So here we go. Here we go with our trace. nextChar gets what? B. Now what is the lowercase b dot? What is the lowercase b? That's the buffer. And we already saw how b dot advanced input works. What will that return? If this is our stream, what will that return? Next char will be what? Will be the hyphen. Because this is streaming from the buffer. Now, is everybody clear on that? Are we good? So there's a hyphen. And then now the rest of this stuff should look kind of familiar because it's like what we did before. Case ls start. Are we in start? Yes. If utility.alpha is alpha next char, is alpha? No. Else if next char is what? Is it hyphen? Is it hyphen? So sign gets what? -1. And what else happens? State gets what? ls sign. So boom, ls sign. And we skip all the else ifs and we go to the break and we go down to the test at the bottom of the loop. State is not equal to stop. True or false? True. State, not a token, instance of T invalid. True, because this is not invalid token. Are you with me? So what do we do? Is everybody clear on this? Got a question?
Have we looked at instance of before?
Yeah, can you tell? That's a good question. We haven't, but can you tell what it means?
Just like test.
Okay, now look, the relationship is, for inheritance is a. A token was initialized to, a token up here was initialized to T empty. Are you with me? So what that test is doing is that's asking what the dynamic type is. Do you remember, here, actually let's review some terminology. Let's come back up here to figure 7.33. Does everybody understand that a token is the abstract type, T empty is the concrete type, and T empty is an A token. So my question is, here's my question. My question is, when we, here in figure 7.35, at the top of get token, when we said A token gets new empty token, my question is, trick question. What is the type of A token? It's a trick question. Is it capital A token, or is it empty token? It's a trick question because it's what? It's both. Remember, it has a static type. The static type is what? Is A token. The what? Yeah, the static, the dynamic type is empty token. So what this is at, now to get back to your question, what this is at, what this instance of, this is testing the dynamic type of the static type A token, for the static type A token, because the A token could be any one of those possible dynamic types. Is everybody clear on this? Instance of. That was a real, I'm glad you asked that question. Does everybody see how that worked? Okay. All right, so we go back to we go back up to the top, and next char gets what? Next char gets what? Now this gets 9, right? Because that's the next one in the stream, because it's advanced input, the buffer.advanced input. Are we good? Is everybody clear? Case ls start. Are we in ls start? Yes or no? So we come down to, are we in ls ident? No. Are we in ls sign? Yeah. Is everybody clear? This is the same way. This is direct code implementation of the finite state machine. Are you with me? Okay. So we're in ls sign. So what is it? If util.isDigit, next char. Next char is 9. Is the util is digit? Is digit? Come on, yes or no? Is digit?
Yes.
Yes. If util.isDigit, next char. So that's true, right? So what happens? Local int value gets what? 10 times local int value. What's 10 times 0? 0. Plus local int value, plus nextchar minus 0. So what number is that? What integer value is that? 9. So this local int value gets 9. Are we good? And state gets what? Gets what? LS integer. All right? And then we break. And then else, and then we break. All right? And we go down to the test. Is the test true still? State not equal to stop, not instance of invalid. True? Come on, true? True, true. Okay, so nextchar gets what? Gets the 3, right? Advance input, right? And switch state, are we in LS start? No. Are we in LS ident? No. Are we in LS sign? No. Are we in LS integer? Yes. Okay, so if util is digit, yes or no? Yes. What is, here comes our nice little code, converting to int on the fly. What's 10 times 9? 90. What's nextchar minus 0? 3. What's 90 plus 3? 93. So what does this int value get? 93. Are we good? We've seen that technique before. Okay, and state gets, we don't change, no, notice that here, with this direct code technique, we don't change the state. So we break, while, are we still good with the while? Yep. So now we come back up to here, case ls, nextchar, now nextchar gets what? H. LS start, yes or no? Case LS start, yes or no? Case LS ident, yes or no? Case LS sign, yes or no? No. Case LS integer. Yeah. If util is digit, nextchar, is digit? Yeah, please. No. So therefore what? Else. Now look what happens. Else what? B dot backup input, because look, we have scanned this H. We went from here to here when we did the scan. So what do we know we have to do? Backup input. Why? Because when we go back to get the next one, it'll be ready to do it in the machine again. Now, is this slick? And then do you see how you have to decide whether to do the backup or not? You're going to be making these decisions in your code, so you have to understand whether you need to do the backup or not. Okay, so we back up the input. All right, so backup input. And now, you guys, we're going to construct, now we are going to create a new concrete object. So what does it say? Now, what does it say? A token gets what? Is this code slick or what? A token gets what? New what? T integer. What's T integer? That's a concrete subclass of the abstract token. And it's parentheses what? Sign. So sign times what? So it's -1 times 93. -93. But now, because that's new, what gets called? The constructor. So what? So we look. Go back to the constructor. Now, is everybody following this good? So we go back to the constructor here for the int. And what is? So you see here, class T integer extends a token. What does the constructor do? Int value gets I. But what was I? What was the parameter? -93. So I don't know. So now this is all right. So now what happens is, let's go back to the code here. So now what happens is, this A token now is no longer an empty token. So boom. Now it is. Now see, I don't know how to write this down notate this, but now this is a what? This is a what? A T integer token. Now this is a T integer token with what value for its attribute? Negative 93.
As a string?
No, definitely, good question. The answer is no, not as a string, as a what? As an int, because its attribute is a type int.
Right.
And we converted it to the integer value on the fly.
Okay.
With negative 93 attribute. Is everybody clear? And now what happens? State gets what? State gets what?
LS stop.
LS stop. Are we good? And so now we break, and when we get to the while, now what does it say? While state is not equal to what? LS stop. But it is equal to LS stop. We don't even have to check, you know, because it's, right? So while state is not equal to, so state not equal to LS stop is false. It doesn't have to check the other one. We break, and now, so we stop out of the loop, and what do we return? We return this token. All right, and then like I said, we haven't seen how this gets called yet, but the next time it gets called, are you with me? The next time it gets called, we set it up so that the cursor is what? In the buffer. We set it up so that the cursor is going to be here. All right, question?
Yeah, so when,
He's saying, like, why do you need the plus?
yeah.
Oh, why do I have to put the plus here in Java? That's just for self-documentation.
Oh, okay.
That was just a style thing. Yeah, oh, I see. Why did I put the plus here? Yeah, or why did I put the plus in the code? That's documentation style.
Okay.
You see, because it's either +1 or -1. It should either be +1 or -1. So that's that plus is kind of to remind us that that is the sign, you know. the little technique, a little self-documenting technique to, yeah. But you're right, it's a little redundant. Yeah, good question, but yeah, it's a style thing. You know, you guys, style is really important. Don't discount style. I've noticed that some of you guys aren't very good at formatting your stuff, and you're all kind of sloppy, and you need to do, you need to format your stuff, and style matter. I'm kind of serious here. You know, when you code professionally, sloppy looking code is bad. I actually had a student come back and tell me, he said, boy, I said, I didn't realize, and I knew he was sloppy. I won't name any names, but but you know, he was notoriously sloppy, and I warned him a little bit, and he came back and he told me, he said, wow, I said, I didn't realize how important it was. So I mean, it is. You can't just, throw stuff around and make it not look good and easy to read, because it's worth money, because people have to read your code, and if it takes them more time to read your code, time is money. So style counts. Anyway, all right. So now the next time this thing gets called, and then string buffer will get what? Or sorry, local string value will get the empty string, and then what? Sign will get +1, and then what? Local int value will get 0, and then what? Sign will get, oh, sorry, I skipped that. I did them out of order. Anyway, and the A token will get what? An empty token. And then what? Lex State will get LS start. Actually, now we're going to see how the identifier gets created. These were all, that gets initialized to nothing. Nextchar got initialized to nothing at that point. Yeah. Here, when we enter the do loop the first time and we do b.advance input, that's when this gets H. Is everybody with me on that? Okay. And then are we in LS start? Yep. Now, you guys, if util.isAlpha next character, is alpha.nextchar is alpha? Yes or no? Is alpha? Yes or no? Yes. Yes. So now look what happens. This is now our string buffer type. It says local string value dot what? Append next char. Do you see that's mutating? That is mutating local string value. It's not saying local string value gets local string value plus the H. It is appending it in place. Fast but dangerous. Sorry, dangerous but fast. Yeah? So that's appending this. So now this, the empty string, having H appended to the empty string is that. Are you with me? And then state gets what? ls ident. Are we good? And we skip all the else ifs, we skip the break, we go to the end, we do the loop. We're not at stop. It's not invalid. We go back. B, advance input, and what happens here? I, are you with me? We do, are we in ls start? No. Are we in ls ident? Yes. Is, here, is it? Is? Yes. So now what do we do? Append. Notice that it's not local string value gets local string value concatenated with I. It appends it in place. Okay? Dangerous but fast. Okay? So that appends it. Boom. I. All right? And then go to the loop, come back up to the top. Come back up to the top. And now b.advance input. Now what is b.advance input going to give us? Yeah, let's suppose that this is the end of the line and it's a new line character. And then this time when we do next char, b.advance input gives us a what? Let's just say this is a new line. Yeah? And switch on state. And so now we go to ident. And now if util is character or is digit, yes or no? No, so we do the else. So now what happens? We back up the input, and now we do what? Yeah, now this gets a what? This gets a T identifier dot 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 with attribute, you know, the one, okay, and it returns that token. Are we good? Now, and etc. So that's, and then you can look at, I think you can look at the rest of the code and see, I don't want to go through every single line, I don't want to demo or do a walkthrough of every single line of code, but I think you can see how this works. Now, I leave you with this, because I think you need to get started. I leave you with this. Here, in figure 7.53, is the multiple token analyzer that you will implement for Monday. And I think you need to get started with this. And I've already done the state, I've already set up the finite state machine for you. Now can you see the start state is ls start, and there's a space, and notice that the digit C goes to ls int 1, and then there can be, you know how you have 0x for the hex digit? Okay? And then the hex, there's ls hex 1 and ls hex 2, and on a hex digit here, and then on a digit. Does everybody see how that? And you see there's a plus or minus to an ls sign, and then on a digit it goes to ls int 2. Are we good? And then on a letter it goes to ls ident. Now what goes to ls dot? What is that dot for? What? It's for the dot commands. Are you with me? That's for the, yeah. Yeah. You need to start coding. I think we have enough information here to where you can code this up. You can code up this get token. You should start coding up this get token. You see what I'm saying? And what about that comma? What does that comma take us to? An addressing mode, right? You can have any number of spaces after the comma, but once you get a letter, then you can have any number of letters after that, right? And then that will give you the addressing mode, because an addressing mode is either comma I or comma D or comma SF or comma C. So we can treat those, for the time being, we treat those just as identifiers. Now, if you have the wrong spelling for an addressing mode, that error will be detected later in the parser. So we just will accumulate them now. Now, does everybody see how you can, are you with me? Can you with this in mind, I think you should start working on getToken. And what we're going to do on Thursday is we will see how getToken gets called and finish up with more. And you don't have an assignment due Thursday. It's to start this. Yeah.
What happens if you have a colon?
Oh, good question. What happens if you have a colon? Colons are for symbols, and fortunately for you, we don't have to do symbols.
Right.
We don't have to do a symbol table. So that's why it's not included in the finite state machine.
Okay.
Good last question. See you next time.